This is lesson 3-2, solving addition and subtraction equations. Get ready for the lesson. Max had some video games. And then he bought 2 more games. Now he has 6 games. He started with an unknown quantity of games, an unknown number of games, represented by the variable x. He bought 2 more. He now has 6 games. X represents the unknown number of games. What addition equation is shown in the example? It would be x plus 2 equals 6. Explain how to solve the equation. What we need to know is what x is. What value for x makes this statement true? How many games did Max have in the beginning? Well, if we do a little experimenting, a little substitution, we can see that Max actually had 4 games. Because 4 plus 2 equals 6. You can solve the equation x plus 2 equals 6 by removing or subtracting the same number of positive tiles from each side of the mat. You can also subtract 2 from each side of the equation. So we can use the mat as a model, we can use the equation, and come up with the same answer. Our goal is to get the variable by itself on one side of the equation. So we remove 2 here, we remove 2 here, we subtract 2 here, we subtract 2 here. Either way, we end up with the value of x being 4. That's the value for the variable that makes this a true statement. Subtracting 2 from each side of an equation illustrates the subtraction property of equality, which says if you subtract the same number from each side of an equation, the 2 sides remain equal. So if a equals b, and I subtract c from a and c from b, my statement of equality still exists. I subtract the same value from both sides of an equation. I still have an equation, or a statement of equality. Solving addition equations. What I'm going to do is I'm going to subtract the same number from both sides of the equation. In this case, you can see that that's 5. What that does is gives me x by itself on one side of the equation. To check that, I would substitute 3 back into my original equation, so I replace the x with a 3. I now have 3 plus 5 equals 8. That is a true statement. That means my sentence is true. So I've solved the equation. The solution is 3. X plus 6 equals 4. Check your solution, solve and check. So I'm going to subtract 6 from both sides. Using the subtraction equation or property of equality, that gives me x by itself on one side of the equation and a value of -2 for x. If I check this solution, I have -2 plus 6 equals 4. That is, in fact, a true statement. So -2 is the solution to this equation. In my 3 examples, y plus 6 equals 9. I'm going to subtract 6 from both sides of the equation. I get y equals 3. If I substitute 3 back into my original equation, I get a true statement, so 3 is the solution to my equation. In B, x plus 3 equals 1. I'm going to subtract 3 from both sides. I get x equals -2. If I substitute -2 back into my original equation, is -3 or -2 plus 3 equal to 1? It is, in fact. 2 to the left and 1 to the right using my slide model, or 2 to the left, 3 to the right gives me 1 for the value of that numerical expression. So in this case, negative 2 is the solution to my equation. In my last example, negative 3 equals a plus 4. Subtract 4 from both sides. A on this side, negative 3 minus 4 becomes negative 3 plus a negative 4. Gives me negative 7. That's a little tricky for most people. Is negative 7, or is negative 3 equal to negative 7 plus 4? Yes, in fact it is. So, negative 7 is the solution to my equation. Clownfish and angelfish are popular tropical fish. An angelfish can grow to be 12 inches long. If an angelfish is 8.5 inches longer than a clownfish, how long is a clownfish? In words, an angelfish is 8.5 inches longer than a clownfish. C represents the length of the clownfish. 12 is the length of the angelfish. 8.5 is added to the length of the clownfish, and that is my equation. 12 equals 8.5 plus C. I use the subtraction and property of equality to subtract 8.5 from each side. I get 3.5 equals C, or 3.5 equals C. My clownfish is then 3.5 inches long. The highest recorded temperature in Warsaw, Missouri is 118 degrees. This is 158 degrees greater than the lowest recorded temperature. So 158 plus C for the lowest, whatever variable you want to use. To solve that, I'm going to subtract 158 from both sides, which gives me negative 40 for C. So the lowest temperature ever recorded in Warsaw, Missouri is negative 40 degrees, or 40 degrees below zero. Similarly, you can use inverse operations and the addition property of equality to solve equations like x minus 2 equals 1. These are different. These are equations where a number is subtracted from the variable. The addition property of equality says if you add the same number to each side of an equation, the two sides remain equal. So, as in my previous example, if A equals B and I add C to both sides of the equation, my equality is maintained. You can see in the example here with numbers, if 5 equals 5 and I add 3 to both sides, 8 equals 8. If I have x minus 2 equals 4 and I add 2 to both sides, I get x equals 6. By adding the same number to both sides of the equation, I have maintained my equality. So, to solve x minus 2 equals 1, I would add 2 to both sides of the equation. Gives me x on one side of the equation by itself, and 3 as the value for x that makes the equation true. You can see here that when I substitute 3 back into my original equation, 3 minus 2 is 1, so that means because this statement is true, that 3 is the solution for this equation. Example E, y minus 3 equals 4. I'm going to add 3 to both sides. Y equals 7. Doesn't ask me to check, I'm going to anyway. 7, is 7 minus 3 equal to 4? Yes, it is. This equation checks. R minus 4 equals negative 2. I'm going to add 4 to both sides of the equation. Gives me R on one side of the equation all by itself. Negative 2 plus 4 is positive 2. Is positive 2 minus 4 equal to negative 2? Yes, in fact it is. I go 2 to the right, 4 to the left. Gives me negative 2. That is the solution of this equation. In my third example, Q minus 8 equals negative 9. I'm going to add 8 to both sides of my equation. Q equals negative 1. Is negative 1 minus 8 equal to 9? Well, negative 1 minus 8 is the same as negative 1 plus a negative 8, which is indeed negative 9. This should be negative 9. So this is, negative 9 is the solution to my equation. pair of shoes costs $25. This is $14 less than the cost of a pair of jeans. Find the cost of a pair of jeans. In words, shoes are $14 less than jeans. J represents the cost of the jeans. So the cost of the shoes, $25, is equal to the cost of the jeans minus $14. I add 14 to both sides of my equation. Gives me J on one side of the equation by itself. It tells me that my jeans cost $39. The average lifespan of a tiger is 22 years. This is 13 years less than a lion. So I'm going to do the life of a lion minus 13. I would add 13 to both sides of my equation. Gives me L all by itself on this side. Tells me that the lion lives to be 35 years old. Solve each equation, check your solution. We'll see if we can get through all of these. Maybe we'll just do some of them. N plus 6 equals 8. Subtract 6 from both sides. N equals 2. Is 2 plus 6 equal to 8? Yes, it is. Number 2, 7 equals y plus 2. Subtract 2 from both sides of the equation. 5 equals y. Is 7 equal to 5 plus 2? Yes, it is. This is the solution. Number 3, m plus 5 equals 3. Subtract 5 from both sides. M equals negative 2. Is negative 2 plus 5 equal to 3? Again, the answer is yes. This is my solution. My fourth problem, negative 2 equals a plus 6. Subtract 6 from both sides. A equals negative 8. Is negative 2 equal to negative 8 plus 6? Yes, it is. The solution to my equation is negative 2. Solve each equation. Check your solution. X minus 5 equals 6. Add 5 to both sides of the equation. X equals 11. Does 11 minus 5 equal 6? Yes, it does. 11 is the solution to my equation. Negative 1 equals C minus 6. Add 6 to both sides of my equation. C equals 5. Is negative 1 equal to 5 minus 6? Yes, it is. The solution to my equation then is 5 equals C. In my last example, it says, President John F. Kennedy was the youngest president to be inaugurated. He was 43 years old. This was 26 years younger than the oldest president to be inaugurated, Ronald Reagan. Write and solve an equation to find out how old Reagan was when he was inaugurated. So Kennedy's age was 43. This was 26 years younger than the oldest president, so we'll use P for president minus 26. We would solve by adding 26 to both sides, which tells us that President Reagan was 69 years old when he was inaugurated president. At this point, you should quit the video, go back to my Moodle page, log in, take lesson quiz 3-2 on my Moodle page. Remember, your username is your 6-digit student number, and your password is the first 6 digits of your last name and your 2-digit birthday.